Okay, next we go to question number 2. The outlet temperature from actual adiabatic compressor that accomplish the same compression given as T2A is equal to 520 Kelvin. Find the actual power output and isentropic efficiency of the compressor. So this question is involving actual power output. So it means that in the outlet of the compressor, we have two states, that is 2S and 2A. And please remember that 2A and 2S only exist at the outlet of compressor or outlet of turbine or outlet of nozzle. Okay? So, how to find actual power output? Okay, the actual power output here is given in a formula of W dot A is equal to M dot WA. Okay, so we want to find WA. How to find WA? Given here, WA is H2A minus H1. So we write down here, WA is equal to H2A minus H1, and since this is air, then we can convert it to Cp T2A minus T1. The same value of Cp, we use 1.005, T2A given as 520 minus 300, then we will get actual work as a 221.1 kilojoule per kilogram. So W dot A is equal to 9.5, the mass flow rate, multiply with 221.1 kilojoule per kilogram, then we get the power input for the actual work is 2100.45 kilowatt. Next, the isentropic efficiency of the compressor. From the formula, we know that it is about the ratio of isentropic work over actual work. Isentropic work we find from the previous question. Okay, WS is 176.01. 176.01 divided by WA here, 221.1, then we will get about 0.796 or 79.6%. So the isentropic for the compressor, the isentropic efficiency of the compressor is 79.6. Thank you.